Hello students, now we are going to see the geometric distribution, its moment generating function, mean and variance. The definition of geometric distribution are as follows. A discrete random variable x is said to follow geometric distribution if its probability mass function is given by p of x equal to q power x minus 1 into p, where x equal to 1, 2, 3 up to infinity. Here p is the parameter and p denotes the probability of success, q denotes the probability of failure, and we know that p plus q equal to 1. Until success, we perform the trials in this distribution. There will be only one success in this distribution. Now we see moment generating function. Since the geometric distribution is a discrete type problem, the formula for the moment generating function is sigma for all x e power tx into p of x. Here x value ranges from 1 to infinity and our p of x is q power x minus 1 into p. Here the variable is x and we can take all the constants out of the summation. Here p is the constant and q power minus 1 we can take it out. It will be written as divided by q, and the remaining terms are e power tx and q power x. We can combine both the terms. We can write it as q e power t whole power x. Now substituting x equal to 1, 2, 3 up to infinity, we get q e power t power 1 plus q e power t power 2 plus q into e power t power 3 plus etc. up to infinity. Here we can take q e power t outside. The remaining terms will be 1 plus q e power t plus q e power t square plus etc. And we know the formula 1 plus x square plus etc. that is equal to 1 minus x whole power minus 1. Now we have the format of this 1 plus x square plus etc. So we can apply this formula here, q e power t 1 minus q e power t power minus 1. Here this q gets cancelled. The remaining terms will be p e power t by 1 minus q e power t. This is our moment generating function of the geometric distribution. Now we can find the mean and variance by using this moment generating function. Differentiating this moment generating function with respect to t, we get in the denominator 1 minus q e power t whole square, 1 minus q e power t denominator as it is. Differentiating the numerator, we get p e power t minus, keeping the numerator as it is, differentiation of the denominator gives q e power t. Here we have used u by v method differentiation. Differentiation of u by v equal to denominator square v du minus u dv. We applied this formula. By simplifying this, we get p e power t minus p q e power 2t plus p q e power 2t divided by 1 minus q e power t whole square. Now these two gets cancelled. Finally, we get m dash of t equal to p e power t divided by 1 minus q e power t whole square. Again differentiating this with respect to t. By using the u by v method differentiation, denominator square, denominator as it is, differentiation of the numerator minus numerator as it is, differentiation of the denominator 2 into 1 minus q e power t into minus q e power t. Now the first order moment expectation of x, that is mean, is obtained by substituting t equal to 0 in m dash of t. M dash of 0 equal to, if you put t equal to 0, e power 0 is equal to 1. So p divided by 1 minus q whole square. We know the formula p plus q equal to 1, which implies p equal to 1 minus q. So instead 1 minus q, we can write p square and gets cancelled 1 by p. Here mean equal to 1 by p. Put t equal to 0 in the second derivative, we get 1 minus q square into p minus 2p into 1 minus q into q. This will become plus, minus into minus plus, by 1 minus q power 4. And again in the place of 1 minus q, we substitute p, and simplifying we get p cube plus 2p square q divided by p power 4. So p cube by p power 4 plus 2p square q by p power 4. Further simplifying, we get 1 by p plus 2, here 2 p square gets cancelled, so 2q by p square. This is m double dash of 0, that is expectation of x square, second order moment. We know the formula of variance. Variance of x equal to expectation of x square minus expectation of x whole square. We have derived this expectation of x square, that is 1 by p plus 2q by p square, and expectation of x is 1 by p, so minus 1 by p square. Taking the LCM of p square and simplifying, we get p plus 2q minus 1 divided by p square. For our convenience, we can write 2q as q plus q minus 1 by p square. And we know that p plus q equal to 1. P plus q equal to 1. So we get 1 plus q minus 1 by p square. 1 gets cancelled. Finally, we get q by p square. That is the variance of x. For the geometric distribution, a moment generating function, we derived m of t equal to p e power t by 1 minus q e power t, mean 1 by p, variance q by p square. Thank you.